Hi guys, good to see you again.
Hi, Mr. Kane.
Yeah.
What's on the board now?
Oh, that there is a thermal image of some of my students that went to on the Argonne field trip on Saturday.
Would you lose them and had to find them?
Yeah, pretty much. Those thermal imaging cameras are great.
It's creepy looking.
All right. So let's go ahead and get started here.
All right.
Looks like what we're doing today is we're going to talk about measurement. We're
The hard stuff.
going to see how you measure up.
All right.
So goals for Unit 6, we want you to be able to measure with precision.
Okay.
We want you to be able to identify how many significant digits there are in a given measurement.
Okay, so sig figs is short for significant figures?
Significant figures. Some people
Okay.
call it significant digits.
Okay.
Okay, so sig figs. I think that's what we usually shorten it to,
Yep,
right?
we're lazy.
It's easier to say that in
Yep.
class. Be able to use sig fig math rules.
Okay.
There are two sets of math rules. Know the values of the metric prefixes. So we've got to memorize some things here.
Memorization's going to go on in this unit, isn't there?
Like you got to know that when you ask for a kilogram of meat, you're asking for 1,000 grams.
Okay.
Okay, that's when you go over to Europe.
Yeah.
And you solve using dimensional analysis.
Okay.
You need to convert using metric units.
So when you do go over to Europe and it's 65 kilometers per hour, you know what speed you're supposed to be doing.
Yeah, exactly. Because if you're going 65 miles an hour, somebody's going to be mad.
Yeah.
Yeah. And then we also need to use scientific notation, which I think is, well, that's easy stuff,
Yeah.
right?
This looks like an interesting chapter. This one might be a toughie, though, huh?
A lot of math involved in here.
Yeah.
I would actually say that if you don't have a non-graphing calculator, you're going to be in trouble.
Yeah.
Because if you have a graphing calculator in class, I don't let you use it.
You don't need a fancy graphing calculator, but you definitely need a calculator for this section and actually for the rest of chemistry.
Yeah, it's got to be able to do scientific notation. Basically, if you can find a log button somewhere on your calculator and it doesn't have a huge screen on it, you're golden.
Yep.
Okay. All right, so we're starting with fundamental measures here.
Okay, length.
Length, the fundamental measure of length is the meter used in the metric system.
When you say fundamental measure, Mr. Kane, what exactly do you mean? The normal way we measure length is in meters?
Yeah, the normal way.
Okay.
The standard, the basic units.
Okay.
I think the standard unit of measure.
Okay, because there
For
are other
each-
units for length, right?
Oh,
But
sure.
We're used to meters. Okay.
But what we call the fundamental measure is the meter.
Okay.
And we can use centimeters, we can use millimeters. Some people use micrometers.
Yeah, those are smaller. That would be crazy to measure like a football field in centimeters, millimeters, and okay.
Volume, the fundamental measure is the liter, which we abbreviate with an L.
Okay.
Liter. There are 1,000 milliliters in a liter, and actually in chemistry, most of the time we wind up measuring things in milliliters because we don't want to use a heck of a lot of stuff.
Yeah.
But the fundamental measure is the liter.
Now that would be for liquids, correct, Mr. Kane? Liters and milliliters?
That would be correct, although you can measure the volume of an object that is a... You can measure the volume of objects that are solid,
Uh-huh.
such as a cube.
Yeah.
You could measure the volume of it by taking the length, the width, and the height. And everybody who's taken geometry or even 8th grade knows that the volume of an object is the length times the width times the height.
Oh, and I bet if those were in centimeters and you multiplied centimeter by centimeter by centimeter, you would get a centimeter cubed for a solid object. Ah, look
And
at that.
the neat part here is a cubic centimeter is the same size as 1 milliliter. So if we say 1 milliliter of water, that's going to be the same as a cubic centimeter of
Okay.
a solid substance.
Yeah.
It's the same volume,
Okay.
not necessarily the same mass
Yes.
or the same density, but
Yeah.
the same volume.
Okay.
All right. Speaking of mass,
Kilograms.
the kilogram, abbreviated with a kg.
G.
Notice a small k, small g.
Yep.
Usually we wind up using grams, but the fundamental measures are the kilogram, the liter, and the meter. I think there's usually like one test question about that.
Measurements and calculations.
Yeah, we got to take measurements.
All right.
All right. Obviously, we've already started doing that in chemistry.
Correct.
We've used some graduated cylinders, some beakers. So one thing to be aware of, we got 3 different kinds of graduated cylinders in our bins.
Uh-huh.
So the thing is that different pieces of glassware have different lines on them. You can see here that this piece of glassware, this beaker, has lines. Each line is worth hundreds. So in between those two lines is 100 milliliters worth of difference.
Well, I wouldn't want to use a beaker to measure out 15.5 milliliters of water, would I?
No, definitely not. This is not a very
that's
precise
no good.
tool.
Okay.
All right, the lines on it aren't going to allow you to do that. So this one measures in hundreds of milliliters. There are beakers that have lines that say tens.
Okay.
This graduated cylinder, though, is measured in ones of milliliters. There are 10 lines between 60 and 70. So this one I might be able to get 15.5
Okay.
milliliters out of.
So that's an increment of 1 mil on the graduated cylinder, correct?
Right. Right. Sorry, I should actually probably write this 1 milliliter per line.
Yeah.
And maybe this should say 100 milliliters per line.
Yeah, okay.
Right?
Yeah.
Okay, because it's per line. So this one I could measure 15.5 milliliters just fine.
Uh-huh.
Okay. Now there are some devices that do tenths of milliliters that we have. The smaller graduated cylinders are measured in,
Okay.
have lines of tenths. And then there are,
Micropipettes, aren't they?
but these are very precise instruments, and they can measure all the way down to the, let's see, what is this? The tenths, hundredths, thousandths, the 10,000ths of a milliliter.
I used to
Okay.
use those when I worked in a hospital lab, Mr. Kane.
You worked in a hospital lab?
I did.
Oh.
Precision. How close a measured value is to its other measured values. If you were to measure the volume of a chemical several times, and 50.4 mils the first time, 50.3 mils the second time, 50.5 mils the third time, all three of them together that's a pretty precise, isn't it? Because
Is
they're
that
almost
precise?
the same thing.
It's almost the same thing. 50.4,
Reproducibility,
50.3,
isn't it?
50.5.
Yeah, that's pretty good.
That's pretty decent in a lab.
Yeah.
Because what's the average here? How do you take an average, Mrs. G?
Let's see. You take an average, you add up those three numbers and divide by 3.
50.4 plus 50.3, 50.5. Real quick here. 7 and 5 is 2. Carry the 1. 161.2. So on my handy-dandy calculator, I take 161.2, and I divide that by 3, and I get 50.4 is how close a measure is to its true value. If you have an experiment where you're wanting to measure your chemicals as close as possible, to being accurate, if you need 46 milliliters, and you measure 45.9, 46, and 46.1 milliliters, that's what we call accuracy.
Because you're getting close to what you want, the 46, is that correct?
Exactly, because you're getting close to what you want. Now, this one, accuracy, the fact that these three are close to each other doesn't have anything to do with anything. That's precision right here, just comparing them to each other.
Yeah.
Comparing them to what you wanted to get,
Is accuracy.
or what you had to get, what the correct answer is where accuracy comes in. So this big arrow here, this is accuracy.
Alright.
Looking at them together is precision.
So of the two terms, Mr. Kane, which one do you think chemistry people actually lean towards more than the other?
Well, something that I've always thought is that in science you can never be perfectly accurate.
Okay.
It's kind of difficult to be perfectly accurate.
Especially when you're doing labs.
Because there's human error, and the devices you're using, sometimes they don't measure well enough.
Yeah.
But what you want to do is you want to try and eliminate that as well as you can with precision.
Okay.
So whenever you take a measurement, you want to be as close to the correct, as close to what you want as possible.
All right.
This is where we have our ability to affect.
Ooh, darts.
Check this out. Oh, we should be able to tell whether these things are accurate or precise.
All right, so this is kind of like your grade, isn't it, in chemistry, Mr. Kane?
100%. This one's shooting right around 100.
And that's what you want, so it's accurate.
Okay, so it's accurate because you want 100. You want the
Right.
bullseye.
And every time you take the 1, 2, 3, 4, 5 tests,
Yeah, there were
you
5.
get almost 100%. So you're very precise.
Yeah, you're consistent, right?
Yes.
Okay.
Reproducibility.
Reproducibility. How about this one? Hey, look. got them all in the same place.
Well, that's precise, all right. You got pretty much, you're consistent.
We got the precision.
Yep, but the accuracy is not good.
Hopefully we're aiming there in the middle.
Yeah,
Yeah,
you've got 10%, so the accuracy is pretty bad, so no accuracy.
Yeah, no accuracy, so this is just precision.
Yes, that is just precision.
Okay, and then this one, hey, check this out. We hit the whole board.
Well,
everywhere.
it's everywhere.
Let's see. Can I check? I can't really check accuracy, can I?
Nope, you're all over the place.
Precision?
10%, 30, nope.
No, because they're not clustered.
Nope, they are not clustered.
So they're not
at
clustered,
all.
and they're not where we want them to be. So this is neither
nothing.
accurate nor precise. So
Nope,
like that.
nope, pretty bad. All right, now Mr. Kane, those are usually called triple beam balances, but I see more than 3. What is this one called?
This is my extra special deluxe
Oh,
balance.
wow.
All right, I see 1, 2, 3, 4
4
beams.
beams.
This is actually quad beam balance.
Whoosh, okay.
I would just call it a beam balance.
All right, so we have to read this measuring device with precision, correct, Mr. Kane?
That's part of the point here, yeah, is that we want to read with precision. I think that was one of our goals
Yep,
for the
that
unit.
was one of the goals.
Okay, so if I'm reading this thing, I guess I start at the back here because it's got the biggest units on it, so
Yeah.
200. So I'd put a 2 in the hundreds place.
Okay, and then I see an 80, so
Okay,
in the tens place would be an 8, yeah.
all right,
And then I see a 9.
okay.
So far, so good.
So far, so good. Now, the ones place, that's the ones place value. So next we
Yeah.
need it looks like a decimal.
Decimal. And then we go into the tenths place, right, Mr. Kane?
There's 7 tenths, there's 8 tenths, there's 9 tenths, and there's 10 tenths. Well, it didn't get to 10 tenths, did it?
Yeah, no, so it'd be 0.9.
0.9. And then 1, 2, 3, 4, 5, 6.
Definitely past the 6.
Definitely past the 6, but not quite to the 7.
No.
So I can say
I
6.
agree. Definitely 6.
And is that an 8?
Ooh.
Or is it a 9?
Well, it's, boy, I don't know. It's past the 5. It's past the halfway mark, correct?
Yeah. Halfway would be about here, so okay, you're going to say about 8. So you're going to say about 8?
I'm going to say about
So
8.
we guess this digit right here, the last digit we do is a guess, and then what do? We still need one more thing to make this a measurement.
Grams.
Grams. There we go.
A unit.
A unit. Units are important.
So you could have guessed the 9 where I guessed an 8, and it would have still been right, correct?
Yeah, I could have put a 9 here.
Okay.
Because the whole definition about this last digit is that it's a guess digit.
Okay.
Okay. Now, some people, well, it's kind of hard to say 7 on that because
Yeah, it's not dead on
it'd be
7.
farther left.
Yeah.
So 8 or 9 probably is a pretty decent.
Okay.
Is pretty decent. And if students had gotten 8 or 9, that would have been perfect.
All
That
right.
would have been fine.
Okay.
Okay. So just to quickly summarize here, guys, the goal of measuring with a device, you look at the device and you find what the value is of the smallest line. You're finding the place value.
Okay.
So these are tenths here. So that means that these divisions in between are hundredths place value. I'm going to guess one place past the hundredths.
Okay.
That's how I know where my guess digit is. It's one place past what the smallest line represents.
All right, so anytime we read a measuring device, because significant figures revolves around measurements, correct?
Mm-hmm.
Anytime we read a measuring device, we have one more number than the smallest increments?
Yes.
Awesome.
Okay. This one's pretty easy, right?
Okay, wait, now let me see. Well, definitely 2.
Right, because do we need the zeros in front?
No.
Yeah, the zeros in front are kind of meaningless.
Yeah, that's
right?
meaningless.
So we don't put the zeros, but we do put the 2.
So I see a 2, and I see a 0.0.
Yeah, it didn't quite get to that
Didn't
point
get to
1.
the point
This is
1.
actually a tough one to do because you got to realize it didn't get to that point 1.
Right, so
So you actually have to put a 0 there.
0.056. It's on the 9th line, so 0.09.
Mm-hmm.
That's what I can read definitely. And then one more number past the increment, so not 0.
Right.
0.090, yeah?
Right, because this is these are with hundredths, so
Yeah.
we have to go. This is the hundredths right here, so we have to go one more place.
So I'd say 0.
All right, you're going to say 0 because it's right on the line.
Yeah. I would say grams, Mr. Kane.
Oh, you're right. This is a balance. Okay.
Yes.
Great.
Ooh, liquid volumes. Okay.
This is a graduated cylinder?
Yes, it is. In increments of 1s, correct?
Yeah, it looks like increments of 1s because there's 60, there's 70, there's about 10 in between.
So if I'm doing this right, my measurement will be one more digit to the right of the 1s place.
Mm-hmm.
Okay, which is a decimal tenth.
Oh, and before we go on, we should discuss what that is.
The meniscus?
The meniscus. I don't think we've talked about that yet. But basically, water, when it gets put in a glass tube like this, tends to actually flow up on the tube.
Yeah,
kind of like
the
that.
Surface tension.
Because the surface tension actually climbs up on the sides. So we always read a meniscus
At
from the bottom part of the reading, just so that we all read exactly the same. That's actually exactly where we want to measure from.
All right, so I see a 60.
60.
And then 1, 2, 3, it's past the third line.
All right.
And then this is going to be our estimate. So I would say it doesn't look exactly halfway. So I would say either 0.3 or 0.4 maybe, yeah?
Okay. I would have went with 0.4, so I'm going to write
And
0.4.
milliliters.
And then you put milliliters, right?
Okay. Yeah. And that, okay. I like.
That's not how I read it now. Ooh!
A
A king!
ruler. A what?
A king!
A king?
Or a queen. Prime Minister? President?
Oh my God. A ruler.
A ruler. Arf.
Something tells me we're going to be doing these videos by our lonesomes very soon.
All right, so anyhow, with this ruler, I think I'm measuring 9 point. And it looks like these are tenths place, so I'll want to go one place past the tenths place.
Right.
I'll go to the hundredths place when I measure. It got 1, 2, it got to 3 tenths.
0.3, yeah.
So I'm going to get 0.3 for sure, and this is where we can debate about it.
Okay.
But I think that that's perfectly centered on that.
Yeah, it's just that the line is thick. It's an awfully thick line, but
It's a
I'd
very
read
thick
it right
line.
in the middle.
I'm going to read it in the middle. All right, 9.35, and since this is a metric ruler,
I'm going to assume centimeters.
we're assuming centimeters.
Okay.
Yeah. Because this can't be inches, because inches are measured.
Okay, guys. On a blank sheet of paper, 1, 2, and 3, let's choose letter J. So 3J, not all of 3, just J. Press pause, get that down, and bring that back to class with your name on it.